Hey, welcome to Google Classroom. Alright, so today's topic is air pressure 101. What does that mean? That means we're going to talk the very basics about air pressure. Now, I know what you're thinking. Air pressure, that has to do with my tires, right? My tires are flat. Well, yes and no. That is one example of air pressure, but believe it or not, air pressure is everywhere all the time. If it wasn't, then we'd be in a vacuum of space, which would be cool, but also not cool for us. So let's just talk about the first thing. Yes, air has weight. Air doesn't have a lot of weight, but we know that it's there. Air is a gas, but in some ways it's also considered like a liquid because it does conform to different containers. For example, my glass right here. Uh, is empty, but it's also full of air. The air has taken the shape of the glass, and no matter how hard I try to do, I can't get it out. So it does take up shape. And I also know that it's kind of like a liquid because if I move my hand back and forth really fast, I can feel it flowing through my fingers. So air does have volume and it does have weight. It's just not very high in terms of mass. Believe it or not, it's actually about an 800 to 1. So, compared to water, that is. So if I were to fill up this cup with water and weigh it, and then I fill it up with air, I would need 800 of these cups of air to equal that 1 cup of water. So that tells you that there's a pretty big difference between the two. It also has to do with swimming. I can walk a lot faster than I can swim. And one of those reasons is because of how densely packed the different molecules are. Okay? So, let's talk a little bit about pressure changes. Air, actually, all energy is going to move from high to low. Everything from high concentration is going to move to low concentration. What are some examples of that? Well, heat is an example of high concentration. So when something gets really hot, it's automatically going to want to cool down. That's why you can't keep a beverage hot. That's why it always goes through and it'll eventually cool down. So coffee mugs are designed to hold in as much heat as they can for as long as they can. Why did they do that? Well, they have what's called a thermal conductivity, which means it doesn't allow the vibration of the molecules to go out as much. Okay, because as much vibration you can keep in there, the warmer it'll stay. So that's actually the flip side of something that is designed to keep things cold. What does it do? Well, it tries to stop that vibration, but the vibration isn't coming from inside of the cup. For example, a Yeti glass does a great job of keeping cold things cold. Why? Because it stops the outside environment from acting upon the glass or the cup. Okay? That's why I get condensation outside of a cold drinking glass. That's why the water molecules form on the outside. Okay? Because it's actually pulling the energy out or pulling energy into. Depends on which way you're looking at it. But it always moves from high to low. So let's talk about air real quick. Air, nice. But I didn't just breathe oxygen. I did, but not just oxygen. Oxygen is the second largest component. About 20% of the air we breathe is oxygen. Most of it is nitrogen. Okay, nitrogen is found other places too. For those of you in the periodic table of elements, if you chose nitrogen, good job. Nitrogen is about 78%. So between 78% and 20%, if my math serves me right, that's about 98%. Ooh, wait a minute. How much is all of air? That's right, 100%. Those of you that shouted out, thank you. Those that didn't, pay more attention. Okay, so if 100% of air, that leaves me with 2%. 2% left for everything else. So what's in that 2%? Well, there's carbon dioxide. That stuff that I just breathed out. By the way, plants need that, not the oxygen that we're taking in. Okay? Yeah, that balance is important. So we'll talk about that later. What else? There's some inert gases, the methane, things like that, different types of gases, and then water vapor. Water vapor is 1% of the air that we breathe, which is good because, we need that moisture. That's why we get chapped and we get that stuff. So um, my question that I'm going to pose to you now is how or why does wind blow or move? I'll give you a hint. It has to do with our title. And then the last thing that I'm going to leave you with is, dang, was that an awesome video watching the steel drum. If you haven't watched the steel drum yet, wait for this to end, right? But then go back, watch it. It's awesome. And then you may be asking yourself, how can I do that at home? Don't worry, I have an idea for you. But you're going to have to wait till a little bit later or message me and I will show you the experiment. Or we may even get together on live and do it on Zoom because I've got a pretty cool idea or something that we could do. All right, so till I see you next time, ladies and gentlemen, have a great week. Remember, this is due somewhere on Tuesday. Get on it. But go through at your pace. Make sure you understand. Take time. Listen. Learn. If you have a question, email me, jbowden@verdoniacast.com. Get a hold of me. Don't fall behind. Stay up on stuff. Remember, you're responsible for your learning, right? I can tell you some stuff. I can show you some cool stuff. But it's up to you to take it from here and put it in here. All right. I'll see you guys later.